Hi, everyone. Welcome. I hope you guys are having a wonderful time here. I've been enjoying this. My first time at HashiConf, and the conferences has been amazing. The talks have been great. And thanks for you guys to stopping by. I'd like to start my talk by talking about this law, which is, I think I made it up, but I think it talks about laws of unintended consequences. And that means essentially, when you're dealing with architecture and you're dealing with new things, stuff will go wrong. And it's mostly the stuff around things that you made decisions around. And it's tricky because in your vision, you have a grand design that you want to take to fruition. What ends up happening is things look like this. And more often than not, you're one surge away from disaster. And that's the reality. And we need to make sure that how do you evolve your architecture and how do you evolve your business continuity practices and new things that you bring into without ending up in this situation. So that's going to be a focus of my talk. I'm going to walk through some of this stuff. Again, my name is Pankesh. I'm a platform architect at Xfinity Mobile. We are a relatively new business unit within Xfinity. We launched 2.5 years ago. My team owns the APIs for the entire platform. So we do all the APIs ranging from the buy flow experience to you're activating the phone if you get a new device and you want to activate the phone, to one of the services I love the most, which is a packaging service. It's almost a nano service which tells the agent which box to ship the phone in. But anyway, I think the key focus that I love to focus on is how do you make sure that you are evolving the platform not just from a functional point of view, but also all the non-functional requirements that are key. So you need an advocate, and that's the advocate. I'm the advocate on that team. So if you guys want to reach me, that's my contact details. If there's stuff that you want to talk about, just Slack me or find me here. I'd love to talk about some of these things. And again, just a standard disclaimer, a lot of stuff that you'll see here is I've just used very standard APIs and open source libraries that are available to you. But take a look at what I'm showing and see how it fits into your work and your architecture, and just adapt and use and see how things work out for you. So I'd like to start this story with going back in time. A lot of us, and this is where I was maybe 12, 15 years back, my first application when I was running looked somewhat like that. It was very simple. It had a UI and just a bunch of application code put together. Mostly on 2 servers, I think, and we had a load balancer and a database server with a couple of firewalls, and life was easy. But then we started getting awareness of data, and we started saying, hey, you know what? Yeah, we need to separate out this logic, and we don't want our UI logic to be where our services are. We want to keep this data piece separate so we can secure it more. And then things started, kind of looking more like that. And then we started getting awareness of domains. You had business owners who were saying, hey, you know what? My domain needs these special things, and I have special requirements around it. So things started getting more fragmented. We were still kind of doing the same MVC, and this is when Spring started coming into being, and people had more tooling to kind of enable this sort of architecture. And then came Agile. And most of you guys already know or have experienced that stuff, that although we are doing the Agile part, things are coming from a business with high velocity, and people want things to be done in a given frame of time, and we want a predictable result outcome out of these services. So we started, kind of breaking these things up, moving teams into future teams, and this is what a lot of us actually in the industry call a modular monolith, right? You're still deploying this application within a container. You're still having this monolith piece of application that gets deployed, but it kind of gives you that velocity, and it gives you that speed of deployment and releasing new features. What it doesn't give you is scalability, right? And that's where, and this is not too long ago, right? I'm talking about 3-4 years back when everybody started saying, hey, you know what? We need to scale these up. And some of this transition was a result of enablers that we are here talking about, right? The Terraforms and the consoles and all of these things that enabled application teams to build an architecture like this. It was kind of all around the scaling piece. It encapsulated the data. And a lot of the stuff is, sorry, wrong clicker. You have different versions, right? And this was a dream for an architect coming back from the days when you were doing monolith and you had a brittle application. You needed to be completely predictable on what you release. This gives you that predictability. You could have one version of an API running and a completely different version of API running. You could move things in and out. Great. And very soon, we could not scale our hardware infrastructure to scale with the microservice layer. So we said, you know what? Cloud is the answer. And it truly is, right? It is what you need to run your business in this day and age. The question that we have to ask ourselves is, was this complexity intended, right? Is it what we wanted? Like, was this a grand plan, or did we just stumble upon this design and this architecture? And I think most of us will agree that, yes, this is intended. What is unintended out of this is some of the complexity that we get. And my argument to that in here is, complexity is fine as long as you can manage that complexity. And that's the rest of my talk. I want to kind of walk you through what it is to manage that complexity and what you want to do in your architecture so that you don't end up with some accidental complexity. On my team, we started looking at this. Some of you guys might have heard this or even used this. It's called a 12-factor principle when dealing with microservices. A lot of this talks about, what do you do with your code base? What do you do with your dependencies? How do you externalize some of your, what do you do with services with scalability point of view? And what do you do with your logs and all? Some of you guys might already be doing this. Even if you are not following this down to the T, you might have come across or started implementing some of these things as part of your day-to-day work, right? One of the things that for us became important and I want to talk about right now is point number 1 and 3. It talks about your code base. The idea being you want to have a single code base that can now be run in multiple environments. And along with that comes a single set of configuration. You want to manage your config. You want to have it stored outside the environment or outside your code in the environment, and you want to move it along with your code, just so that you can predictably release stuff. And I know there were a couple of people who gave a talk around drifts in your configuration and drift in your code, and how do you manage that across your dev lifecycle. So we have, I think, roughly about close to 95 or 98 services right now. That number keeps changing, so I think I have to put the asterisk there. But and across 6 environments, deploying them, managing them, making sure it's consistent, and doing it in a 6-week release cycle is tremendously hard if you do not follow a very disciplined approach. And one of the stuff we started doing is, with regards to config, there were a whole lot of configs that we want to manage. We are a Spring Boot microservice shop. So Spring has a really good library called Spring Cloud Config. It lets you manage configuration as code. Essentially, what you do is you move all your code into a Git repository, and as you migrate your application code, so you version your configuration as well, and you manage them both together and move them both together along. One of the things that naturally happens as part of configuration is you end up with a lot of secrets in your configuration, your DB passwords, your API keys, your service credentials, etc. And unfortunately for us, that started showing up in Git as well. Now, I don't know about you guys, but I don't want to be in a position where I have to support that or stand against that design pattern in a security audit, right? That's not a win-win situation at all. You're going to lose that argument all along. So we started talking about, hey, what are we going to do with this situation that we are in now? And somebody said, hey, why don't you encrypt this? Great, yes, we could encrypt it, but encryption is never a solution to the problem because you always end up with a chicken and egg problem, right? Where am I going to put my encryption key? Where is that key 0? And what do I do with it? And how do I make sure it's secure and it moves along the environment as my code is moving along? So we clearly needed a situation, we needed a design pattern or something to help us. And HashiCorp Vault, we stumbled upon it. There was an enterprise team within Comcast who was standing up security as a service platform. So I started looking at that, and it worked. It seemed like a great fit for us because it had really good seamless integration into the Spring ecosystem. Very clean REST APIs, right? I mean, Preeti was here in the morning talking about, what a good application is and what a good supportable library needs to be like. And that's what it was. It had really clean APIs. It was light, flexible. I didn't have to tightly couple it into my architecture. I could loosely couple it and still use it the way I wanted it. It supported all the authentication mechanisms that we wanted to use. So we were not locked into using it. It was not very opinionated, which is good in some cases, and absolutely in this case it was. And then I had a team that was standing up this whole platform. So one of the things I don't want to do is I'm on the application platform team. I am wary of standing up yet another platform that I need to run and support, which is not my core business capability. So we had a team that was standing this up, so it kind of just fell in our laps almost to say this. So this is what it looked like. My architecture was, we thought we'll do this. We had microservices, we had the cloud config server. We would move our configurations into Git. We would move all our secrets into Vault. And config server would log into Vault. And, it would be seamless. So let's do a quick demo. Let's see what that looks like. I'm going to flip this around. So what I will show you here is, once the screen comes back. So the first thing we did is we said, okay, you know what, let's see what this structure looks like. So we started storing so my setup, I have Docker running the Vault in a very basic configuration. So don't go by some of the stuff that you'll see here, but the idea still holds true. We published all of our secrets. So what you see here is that's the name of the microservice. And I said, in that path, I'll create microservice-based path variables and put secrets there. So what you see here is I have a HashiConf username and password put in my configuration. The second thing here that Spring Cloud provides you is it provides you what is called a Spring config server. And if you guys are familiar with it, I'll show you guys the configuration, what it looks like. This is essentially what the configuration looks like. So before we started integrating Vault, we only had the Git as a source for all of our configs. So it was very simple for me. Again, the deep integration of Spring into Vault. All I needed to do is just provide this block here. I needed to give the host port, the key scheme, and then the interesting thing is I could give this order, which is a priority. I could say, hey, you know what? If there's a config that's available in Vault and in GitHub, take Vault as a priority, and boom. So that stood up my config server. So let's see what that looks like if I start this up. Just going to run in the back here while this is starting up. Once it's ready, what I want to do is I want to show you guys, this is running on port 8762. And this is me trying to get the configs. So now I've gotten one step. I was able to show you that the configs are available from Docker or from Vault. And now I was able to pull those configs from my config server as well. So great, I made one step. I solved that jump between the config server and now that's talking to Vault. I had to pass the Vault token, but that's fine, right? I just have one config server running, and if I need to configure that with Vault token, great. So now let's see what it took me to get my services also connected to this config server. One of the things that I realized as soon as we started doing this is to start my services, as soon as my config server is talking to Vault, all of the clients that talk to that config server now also need to be Vault aware. So I actually had to now pass these Vault tokens as part of starting up my microservices. Now this is where we started getting a little uncomfortable, because what started happening is now the dependency and the awareness of Vault was trickling and percolating through other aspects of my architecture. Not just the config server needed to know this, but all of the microservices that we had needed to know this. And essentially, that also meant that the deployment architecture, or whatever the deployment methodology is that is starting my services, now also needed to be aware of Vault, get that Vault auth token, and pass it to the service on startup. So this is where we were at, and we started questioning this, but let me show you what that looks like. At least the fact that it works the way it's supposed to work, even though we had some of these concerns. And once this comes up, try to get it as fast as it could. But yeah, it's up now. Good, great. So the service is running on port 8082. And if I were to call this, I have my services. So what does the code look behind this? It looks somewhat like that. Again, in the, let me make this bigger so you guys can see. In the true nature of Spring, right? Spring is very convention by configuration. So if you follow the convention, which is, all I had to do is I had to annotate this class with the configuration. I had to give it the prefix. If you guys remember the other screen I showed you, it was prefixed with HashiConf and then my username password. As soon as I do this, that's all I need to do. Automatically, the configs will come in, and based on my preference, whether they are coming from Git or Vault, my configs kind of flowed through. So this part was fabulous, but the other pieces were not so much. So let's get back to what do we think about this? Once we had this implemented and up and running, we started asking ourselves, is this, wait for this to come up, I guess. Yep, there we go. So that's what it looked like. I'll forward through some of the stuff. I showed you this here. What did we like about this, right? I loved the fact that this was minimal change to my existing code and configuration. I didn't have to do much. All I had to do is configure Vault and move all the secrets over there. And then I could control the rollout per microservice. I didn't have to go through a big bang. I could say, you know what, here are the set of services, here are a set of environments, we're going to roll this out, and that looked great. What we didn't like is the fact that I needed to now pass this token at startup. And now my configs were in two places. They were, and people might say, hey, you know what, yeah, you're not talking about configs, now you're talking about secrets. But that's besides the point. The point is for my services to start up, I need to make sure that both of these things move in parallel, and I don't want to keep track of one without being aware of the other. So we didn't think that was a great thing. I could not do an atomic commit and move all of these things together. So that's something we were not too jazzed about. And the other thing we found out is at least this library it didn't support all of the authentication mechanism. We wanted to use the app role, and it didn't have native supports for any of this stuff. So again, we would have to move all of this into our deployment architecture, which is not the most ideal solution. So we were like, hey, let's get back to the drawing board and see what we would like to do with this, or what is it that we want to do with this. So we said, hey, you know what? While this is what it looked like, one of the things we want to do is we always want to integrate tightly, but we want to couple loosely. Right? You don't want to have tight coupling with other aspects of your architecture. How do we get to that is the question that we wanted to ask ourselves. So one of the things we said, hey, let's do this. The secrets that we have in Vault, what if we go back to what we were saying and encrypt them and put them in GitHub? You're like, okay, let's take that for our spin. Let's see how far we can go with that approach. That let me disconnect my config server from Vault. Now my config server didn't need to know about Vault. I'm like, okay, that's one less coupling that I need to worry about in my architecture. And then what do I need to do then? I'm like, okay, instead of I have to log into Vault anyways, what if I just use the master encryption key? Instead of storing all the configs, I'll just store the encryption key. And that solves the issue that I had with what do I do with encryption keys, right? That's a secure place to put my encryption key. I get all the auditing around it. I get all the access control that Vault provides me, all the goodness from that. So I'm like, okay, that seems like a good approach. So we changed our dependency from Spring Cloud Config to this other library called Spring Vault Core. What does it provide you? It provides a really, if you guys have used any of the Spring kind of frameworks or Spring libraries, it provides a very similar approach. Just like with REST template and JDBC template, it provides a Vault template. It makes reading, writing, modifying, deleting API or keys from Vault very simple. It manages all your token. Once you establish the authentication template, you don't have to manage the token or the lifecycle of the token there. And then it also supports all of the various authentication mechanisms that are part of Vault. So it's pretty robust. That's what it looks like. All you have to do to initialize the template is you have to give an endpoint and give the client authentication. The endpoint is very simple. You just construct it based on the URI or the path. And the client authentication is a little more involved, but just 10 lines of code or even less, right? All you have to do is figure out what your authentication is going to be. We were using app role, and you just need to pass in the initial token and the auth path to Vault. So give or take within a few lines of code, we were able to integrate with Vault, get the master key, and seamlessly put this in our code base. And then once you have the Vault template initialized, you can read any path just using that. Now this, in the behind the scene, this still goes through all of the ACLs and all the rules that you've put in Vault and who has access to what. So in our case, we were using GitHub as our base authentication. So groups within GitHub had access to certain paths in Vault. And so this will still honor all of that. I didn't have to worry about that. Externally, the Vault team was taking care of all of that for us. But this gave me a very simplistic API to reach into Vault and pull all that I wanted. So let's take a look at what that looks like. So again, coming back to a very similar approach, what we did now is instead of storing the actual username password, I'm just storing the master key. Now, if you see in the path here, what I've done is I am still storing it by microservice, but I've also said I'm going to make it environment specific. So we wanted to have environment specific master key. I didn't want to use a single key for all my environments. So this kind of gives me that capability. And let's take a look at what happened to my config server now. So my config server configs now look, technically this should be Git, but because I needed to run two demos together, I'm pointing to a local file system for configs, but this would be Git. So essentially what it's happening here is, as the picture showed, my config server is now only pointing to Git to get all of the configurations. What do these configurations look like? I'll show you a couple of examples of what this config look like. So now this is what my config look like, and I'll talk through some of this stuff as well. One of the things you'll notice here is, I have password here in clear text. So what do? That's definitely not what I want going in my Git. One of the things we started doing is, so let me start up my config server, and I will also start up my microservice. And while we wait for it, one of the things we realized is, as part of my microservice starting up, I needed to provide these libraries that are easy to use for the developers. So one of the things we did is we provided a library that lets the developer do the encryption. So essentially what I would do as a developer is I would, if I'm integrating with a new API or integrating with a new service, I have the service credentials. I want to store them and make sure that it's in my environment along with my code. I would take the credentials and I would call this endpoint. It's an encryption endpoint. And I would give it the key that I need to encrypt, and I would give it the environment. Now, behind the scene, what's happening is this library is going to go talk to Vault, go get the master key, encrypt this stuff, and return back to the developer the encrypted value. Now, all the developer had to do is take this and stick it in the configuration. Right? So I would replace this with that. But I'm not done yet, because I have done the encryption part, but I still need a way at runtime to be able to decrypt it. So what does that look like? So if you guys saw a similar code that I had shown you before, again, very similar, I'm going to replace this with a library that we created. It's called keyutil. So this is what it looks like. And let's see. That's it. And let's restart this service. And let's see if it's taken effect. Wait for it to start up. And the idea here would be that this service is now using config server as a backend, which is going to Git. It's going to go get that configuration. It sees those prefixes in there, VLT, which knows that it's an encrypted key. It knows it has to go talk to Vault. It's already initialized Vault, go gets the master key and decrypts this. So let's see what that looks like. Great. So I think, so let's go back and let's talk through what did we do as a result of this. Cool. So what did we do? We gave the developers a starter. Like in Spring, there's the idea of starter dependency. So we gave them a Vault starter. All they had to do is just include that starter in their dependency, and all of the stuff automatically gets wired in. It wires in the endpoint to, so we give them, it encapsulated away all the dependencies to talk to, how do you get the master key and how do you, what do you do with that? So they didn't have to worry about how to get it and how to retrieve it. We gave them a Java API that decrypts the stuff for them. So you saw that I used that in my code. Just a util library that gets auto-wired in. They didn't have to worry about how the auto-wiring is happening or where the details of that were. They could just auto-wire that automatically. And we gave them a REST API to encrypt the stuff. All of this stuff was done without them having any awareness of where the keys were or where the keys were coming from. So what are the benefits we gained, right? I think if you compare with the previous solution, what we got with this is I had my secrets and my configs all in one place in GitHub. And they were secured in GitHub. I could do an atomic commit. I could test this in different environments. I could validate it all the way through my build pipelines. And I knew that when I was pushing a version of my code, its corresponding version of config was also moving in. I didn't have to orchestrate that with the Vault team and making sure that they are also pushing the configs or making it live at the same time, right? So I got atomic capability, and I got the, one of the 12 factors is I can move code and config together. I got that. The dependency to Vault moved to just one key value pair per environment. And this is, we kind of overlook this stuff, but this is important. What I did now is I've made sure that when my application is scaling up, and when I have a burst in traffic, or when I have something going on where I'm getting a whole lot of requests, I'm not overloading the Vault platform as well, right? My problem doesn't become their problem. If I'm on a bridge for some reason, I don't also need to involve the Vault team. Secondly, if I'm scaling up, I'm adding a whole new set of services, we are preparing for an event, I don't need to have the corresponding peers on the Vault team also be ready for that event, right? It's a non-event for them. An event for me should not trickle down to the rest of the architecture on our side. So that kind of gave us the really nice kind of separation between these two. And again, this continued to be a no big bang approach. I could roll it per microservice without having to go through, it as a big bang approach. So things felt good. Things felt right. There were some unforeseen benefits. Now, this is stuff happens when, again, things go wrong, and sometimes things can go right if you do things the right way, or at least approach things and kind of are very, very meticulous and very decisive about what you do. One of the things we realized that our dependency for Vault now moved to Bootstrap. Because my library was reaching out and getting the encryption key at startup, after my services were up and running, if for some reason I lost connectivity to Vault, or there was a network partition or some firewall issues and I couldn't reach out to Vault, I didn't care. My services would be up and running. The only time I would worry about it is if the services were scaling up or if the new services were starting up. So that was a really good side effect. I decoupled my application as I was mentioning before, so they didn't have to know about my kind of scaling and burst traffic scenarios. And all of the keys were completely secure. A developer could use it, but they didn't need to know where it came from or what the details of that were. So that's what the approach is. That's what it looked like, completely clean from our point of view. So what do I want to talk about as key takeaways from this, right? From my experience, what I want to share. If you guys are a Spring shop or you have dev teams that are working with Spring, Spring offers some really good libraries, mostly three, really production-grade libraries with an awesome open source community behind it and some great committers. The Vault is if you want to do direct low and high-level integration to Vault, which is what we ended up using in the end. If you guys are not a microservice application, but you are still deployed in the cloud, you can use the Spring Vault as a library. And lastly, if you're a team that has a few handful microservices, not a whole lot, and it's relatively simple and you want to use Spring Cloud Config, that's another very great library to continue and utilize as well. The other thing I want to bring up is, one of the things we found out is, security doesn't have to be overweight or heavyweight or cumbersome to use, right? You can aim for simplicity, and with some of the toolings that HashiCorp has given us, that's absolutely possible. You can make it simple to use. And if you keep it simple for your teams, your developers, your test automation folks, your DevOps folks, if it's simple and you give them the APIs, they're not going to try to figure out a way around your architecture protocols, right? Your security protocols. They'll follow that because you've kind of designed for usability for them as well. And again, lastly, integrate tightly, but do not couple tightly. Couple loosely so that you can move around without having to drag everybody else along with you. And again, security is a key feature, so just design for it. Just like its scalability, security is also important. Make sure you're very deliberate about your architecture decisions so you don't end up with an accidental complexity. You don't end up with accidental, like what ends up happening sometimes is we go and read an article or we read a book and we just implement it the way we see, but it might not be a good fit for you. So try some libraries, test them out, iterate through that process, and if it doesn't feel right, just ask yourself and kind of follow different approach. It's completely fine as long as it fits your architectural need and scales along the way you want it to. That's my talk. Thanks, everyone. If you have questions, reach out to me or find me here. Thanks.